Good morning, class. Today we are going to be going over similar triangles. And I wish this one had a paper on top, but this is what we're going to do, similar triangles. So think about it if you had a triangle and you shrink it down. The triangle is going to be the same, it's a little smaller or it's a little bigger. Now, there are three ways we can say that triangles are similar. We can do it the first one by angle similarity, and that's what this little squiggly line means. I do want you to add it. It means that if we have two triangles that are the same, then the triangles are similar. And we have to have one angle that is the same in each one. And we put in one little mark in our triangle. And if say that was 30 degrees, the next one, if it was 60 degrees, we'd put 2 marks because both of them have the 60 degrees. The next one we're going to talk about is SAS. SAS is side, angle, side. Similarity. So this means that the angle has to be between the two sides. And the two sides have to have the same scale factor or the same dilation. They had to be multiplied by the same number. And we'll show you how to do that in a minute. But as you can see in our picture, the angle has to be between the two sides. The last one is side similarity. And add that little similarity symbol instead of having to write the whole word. Side means that all three sides have to have the same scale factor in order for it to be similar. If it's not, if one of them does not have the same scale factor, we automatically will say it's not similar. Now, if you go to the inside, we have some examples. So the first one, we have to see if they are similar. And if so, we're going to write a similarity statement. So the first thing I like to see is when we have one triangle inside of another one, means there are two triangles here. So here's our first triangle. And usually you do want to color it in. Or what I like to do is I like to break it up. We know this is 82 degrees. This is W, X, V. And the second triangle is much bigger, but I'm not going to draw it as big. It also has 82 degrees, Z, X, Y. Oops. Let me put that down. Okay. So looking at these two, we can see they both have 82 degrees, so we can draw that one arc at 82. And they both have the letter X. Both of them have X. So automatically, they are going to be the same because one was on top of each other. Now, since we have two angles that are similar, we can say it's angle, similarity. This is how they are similar. Now, to write a similarity statement, we go triangle, and I'm just going to pick from my first triangle here. I'm just going to pick XWB is similar, and I want to go in the same direction. If you noticed, my first angle, the first letter had the two arcs. So in the second triangle, I do have to start with that same one that has two arcs. The second letter had the one arc, so I'm going to have to do that. And the third one has no arc. And so that's how we prove they are similar. And let's go on to the next one. All right, so these two are similar. State how they are and write a similarity statement. First thing I see when I see this picture is bow ties. And you guys know me with bow ties, I always think vertical angles. And I just like to put this on here. So vertical, these are vertical. So we already know these are equal. Now the next thing we can see is that we have two lines that have little arrows through them. what this little arrow means is that they are parallel. So two lines that are parallel cut by a transversal, we can say that these two are equal because these are alternate interior angles. So alternate interior angles. And we just proved the two angles are similar. So AA, similarity. And to write the statement, I'm going to start with my left triangle. I'm going to go from one arc to two arcs. So H, K, and then to the no arc. Do it however you want. Just make sure that the first letters, second letters, third letters all match up. And again, with the right triangle, I started with the one arc, the two arc, and the three arc. And there's your statement. Okay, number 3. Here, we automatically can see we have 120 degrees. So we know we have an A. But I see that we have two sides. So I'm thinking, but we still have to prove it, I'm thinking it's going to be SAS similarity, because we have two sides and an angle. Now, we can prove the angles are same. But to do the sides, we're going to have to prove that the two sides have the same scale factor. Now, the way I like to do it, keep hitting that side, is I like to go from small triangle to large triangle. You don't have to write this for everyone, but I like to have it in the notes. And what this means is that the top number out of all of our fractions all have to be from the small triangle. And everything on the denominator or on the bottom of the fraction have to be from the large triangle. And going from there, I like to start with the small side to the small side. And we're just going to make a fraction. And then I'm going to do large side to large side. And I do like to do different shapes because it makes it easier for me. And then we're going to get out the calculator, and you can either reduce it to a decimal or you can use the fraction button. And if you don't know the fraction button, it's A, B, C. This is the fraction button. It's third line from the top, the second button on our calculator. So if I did it as a fraction, I would get 2/3. But if I did it as a decimal, I would get 0.666666. And when it repeats, I just put a line over it, whatever numbers are going to repeat. And then I do it for the same one. For the next one, I do the same thing with the next one. And I get 2/3, which is 0.66. Okay, these two are the same. So we're going to go, we can say it is similar by side angle side. And again, I'm going to start with my small side. I'm going to go to my 120 degrees. So that's M, N, L. And I'm going to start with my small side going to the 120. So P, R, and the side on the large. Okay. If these numbers were not the same, then we would just write not similar. Okay. Now with this one, I do not like it when the one triangle is on top of the other because I have had so many students get this one confused. It's much easier to break it up. So we're going to take the small triangle, so L, K, M, 6 and 10. Then I'm going to take the large triangle, L, E, J. Now, L to E is this whole length. And to find the whole length, I'm adding up the 3 and 6. So it's going to be 9. And the L to the J, I'm going to add them up, and that will be 15. And now it's much easier to see how they are. But we only have two sides here. So we can't say it is SSS because we need another side to be SSS. It's not AA because we don't have two angles. So I'm thinking SAS, but in order to prove it, we need to have at least one angle that they have in common. And if we look at it, they are sharing that top angle L. So it is proving it, they do. Now we're going to take the small side to the small side. And again, I like to do from small triangle to big triangle or left triangle to right triangle, but you have to stay consistent. So I'm going to go 6 over 9 and then 10 over 15. If for some reason you wrote 15 over 10, you will get a different number. We don't want that. We want it to be 10 over 15. And reduce it. And this time I'm going to go as a decimal. And 10 divided by 15 is 0.6. So these are side angle side. And writing the statement, so triangle. I'm going to go from my small side to my similar angle. Oops. Keep hitting that one button. Sorry, guys. So I'm going to go KLM is similar to triangle E, and you always have to have the triangle button there, or the triangle symbol, ELJ. All right, last two. Okay, and if we look at these, we have no angles. No angles are given to us. No vertical angles, no alternate interior, exterior, anything like that, or corresponding. So we have to, all that we're given is three sides. So I'm thinking it's going to be SS similarity. We just need to prove it. So again, like we proved all the sides, we're going to do that again. So I'm going to go from the small side to the small side. See, this time they flipped that bottom right triangle. It's not lining up on the same side. So on the top left, the small triangle, it's on the left side, but on the bottom triangle, it's on the right. So I'm going to go 7 over 21. Then I'm going to go for the medium side to the medium side. And then the large to the large. I just do the different shapes to help me keep organized. And then you're going to divide it, do it by fraction or by a number. I'm fine with either one. This one is 0.3 and it repeats. This one is 0.4. And then 15 divided by 45, we get 0.3. Automatically, we can see that the second one is different. Now, if we have one that is different, we can stop right there and just say not similar. If one of them doesn't go along with the others, it's not similar. Okay. Try the last one. Again, break it up like we've been doing. We're going to have a small triangle. Okay. And a large triangle. And they don't have to be perfect. Now, the thing with this one, we know that they're overlapping at L. And we do know that L are going to be equal. And if all the sides are also going to be equal, this could actually be proven two different ways. It could be SSS or SAS. So it doesn't really matter. We just have to prove one of them. And now this time, the large one is 88. But this top part right here, we don't know. We do know that if I had 56 plus something, it should equal 88. I'm going to go 88 minus 56, and that's going to tell me that this is 32. And I can do the same thing on the other side. I can go 143 minus 91. and I will get 52 here. And we get the bottom numbers, 44 and 121. Now we're going to set up our statements and see our proportions to see if they work. So small to small, the medium to medium, and then the large to the large. And then you go onto your calculators. And I'm going to get 0.36 and 3 sixes. The 3 and the 6 repeat. Okay, so far it looks promising. They are similar so far. Now, if we can get the last one to be the same, it will be. We can say that this one is side, 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 similar. And then if our statement, so triangle, and I'm going to go KLM is similar to triangle DLE, and I'm squeezing it in if I can. Okay, make sure you have these written in your notes, and you're going to then get the assignment. Check online. If it is a paper, it will be handed out. If it is going to be on Desmos, I will have it on our Google Classroom, but it will be up wherever you need to see it. All right, good luck with this. And then tomorrow we're going to be solving for a missing side. So if we're told that they are similar, how can we prove that? How can we find the missing side of another triangle? All right, good luck, and I will see you guys on Wednesday.